Good morning, students. In last lecture, we have discussed electric dipole. What is electric dipole? Electric field due to electric dipole. Two cases. First on axis of electric dipole and second on equator of electric dipole. Now in this lecture, we will study what is behavior of electric dipole. Behavior means when dipole is placed in uniform electric field. When dipole is placed in non-uniform electric field, then what happens with electric dipole? We will study in this lecture. Today, 27th March, lecture 1. Topic name is dipole in a uniform external electric field. Dipole in a uniform. What is meaning of uniform? Uniform external field means value of electric field at each and every point is same. Value of electric field at each and every point is same. So it is first case we have to study dipole in a uniform external field. See in figure. It is uniform external field, vertically upward direction. We know that external electric field, it is from positive charge towards negative charge. Okay, in this uniform electric field, we have one electric dipole. See, minus q charge, plus q charge, separated by distance 2a. What is electric dipole moment's direction? From negative charge to positive charge. So it is direction of p. Clear? Now, in this theory, we have to assume one angle. That is, let theta is angle between P and E. P means electric dipole moment. E means external uniform electric field. So, it is direction of P. It is direction of E. What is angle between them? Theta. So, theta is angle between P and E. Figure clear? Okay. You have to write C. Consider a permanent dipole of dipole moment P in uniform external field E as shown in figure. Okay. As these two charges are placed in external field, we know that when charge is placed in external field, force is acting on it. See, minus q charge. Force acting on minus q charge. As it is minus charge. Remember, force acting on negative charge is in opposite direction of electric field. How? See, electric field is from positive charge towards negative charge. It is negative charge, so obviously this negative charge is attracted towards positive charge and it is repelled with negative charge. So force acting on this minus q charge is in opposite direction of electric field, and this force is minus QE. Why minus QE? Because this force is acting in opposite direction of electric field. While force acting on positive charge, is in direction of electric field. So this force is plus QE. Why plus? Because it is in direction of electric field. Clear? Now see, force acting on minus q charge, minus QE. Force acting on plus q charge, plus QE. What is total force acting on system? Minus QE plus QE is equal to 0. What is total force acting on this system of dipole? 0. Total force is 0. You have to remember this one important note. In uniform electric field, total force acting on dipole is 0. Total force acting on dipole is 0. Yes, very good. Now see in figure, we have two forces, minus QE plus QE. Magnitude QE and QE means magnitude are equal, direction opposite, and these two forces are not collinear. See, it is line of action of minus QE. It is line of action of plus QE. They are parallel to each other. they will never intersect each other. Means we have two forces of equal magnitude, opposite direction and not collinear. Then yes, you have studied in 11th. Such two forces will form a couple, and due to couple, torque is acting. Due to couple, torque is acting. See here, charges are separated, so forces act at different points, resulting a torque on the dipole due to couple. And due to couple, what is magnitude of torque? What is equation of torque? Magnitude of torque is equal to magnitude of each force into perpendicular distance between two forces. Perpendicular distance between two forces. Now magnitude of each force, we know it is QE. Question is, what is distance between two forces? How to find? See here. Two forces minus QE, it is its line of action. Plus QE, it is its line of action. What is distance between them? If you say it is 2a, then it is wrong. 2a is distance between minus q charge and plus q charge. It is perpendicular distance between two forces. See, is this 2a distance, is this line perpendicular to this line of action? Is it making angle 90? No, it is not making angle 90. What is meaning of perpendicular distance? It is line of action. It is line of action. If I draw a line like this, see, this line is normal to this line of action. This line is also normal to this line of action. It is called perpendicular distance. So perpendicular distance between two forces is this dotted line. So you have to find this. See how? We have assumed the angle between P and E is theta. If this angle is theta, we can say this angle is also theta because it is uniform electric field. This distance is 2a. Theta. This side is opposite side and it is hypotenuse. Opposite side, hypotenuse. Opposite side, hypotenuse. Then which trigonometric function you have to consider? Yes, sin theta. So see, from figure we can write sin theta is equal to sin theta means opposite side upon hypotenuse. Opposite side, that it is named CD. That it is named CD. So it is CD upon what is hypotenuse? It is 2a. So CD is equal to, it is 2a sin theta. Clear? Perpendicular distance between two forces is 2a sin theta. So here perpendicular distance between two forces is 2a sin theta. Okay. So torque tau is equal to QE, that is magnitude of force. It is perpendicular distance between two forces. Simplify. Q into 2a E sin theta. Q into 2a, we know it is electric dipole moment. So tau is equal to PE sin theta. Now see an important thing. P, electric dipole moment, vector quantity. E, electric field, vector quantity. And we also know that torque is vector quantity. If product of two vector is also vector, then which type of product is possible between them? Dot product or cross product? Cross product. So we can write tau is equal, that is torque is equal to P cross E. Why cross? What is reason? Okay, there is cross product between P and E. Okay, because P is vector, E is vector, and the result tau is also vector. Okay, so torque tau is equal to P cross E. Torque tau is equal to P cross E. Its direction, it is vector quantity. So what is its direction? Its direction is normal to paper coming out of it. See how to find direction of torque. How to find direction of torque? Two vectors, P cross E. Put your hand in direction of P, right hand in direction of P. Wrap your fingers in direction of E. Then this stretched thumb gives direction of torque. It is perpendicular, normal to this board. For you it is paper. normal to this paper coming outside. So it is how to find direction of torque. It is how to find direction of torque. And we know that due to torque, system is performing rotational motion. System is performing rotational motion. See here, it is dipole. Dipole moment is in this direction. Electric field is vertically upward. Torque is acting on it, and due to this torque, dipole will align. Due to this torque, dipole will align. Dipole will align till it aligns in the direction of electric field. When E is parallel to P, means electric dipole moment is in direction of electric field, torque acting on it is zero. Torque acting on it is zero. Clear? So see, this torque will tend to align the dipole with the field E. Okay. When P is aligned with E, the torque is zero. See, as shown in figures, it is minus q charge, it is plus q charge. So electric dipole moment, it is from negative charge to positive charge. When P is parallel to E, it aligns in direction of electric field. Theta angle between them will be zero. So torque is zero. So in this case, torque is zero and force is zero. See, remember one point. Force on dipole in uniform electric field in each and every situation, in each and every case is zero. Torque depends how electric dipole is aligned in electric field. Clear? Force is always zero. Torque depends. It depends on angle between P and E. So it is all about when electric dipole is placed in uniform external field. Second case is in a non-uniform electric field. In a non-uniform electric field, net force will be non-zero. Why non-zero? Because non-uniform electric field means as distance or points are changed, value of electric field also changes. So it is not possible. Okay, force acting on plus q charge and force acting on minus q charge, they have equal magnitude. They will have obviously different magnitude. So resultant force is non-zero. Yes, there will be a torque. There will be a torque when P and E, that is angle between them. But when E is parallel or anti-parallel to P, torque will be zero. Torque will be zero. So you have to remember, in a uniform electric field, force is always zero. In a non-uniform electric field, force is always non-zero. And in both cases, torque depends on angle between P and E. Once electric dipole aligns in direction of electric field, torque will be zero. Torque will be zero. So it is behavior of electric dipole in uniform electric field and non-uniform electric field. Write down this whole topic in your notebook. Write down this whole topic in your notebook. Okay, for knowledge students, send notes on my personal WhatsApp number, and other school students, you have to write this in your notebook and send to your subject teachers.